Hello, good evening. Today we will like to presenting our research with the title Comparative Analysis of K-nearest neighbor and decision tree in detecting distributed denial of service attacks. The most frightening attack in the network or system is when your system gets flooded by an attacker. Flooding is generated by the attacker by generating a huge amount of packets and sending it to the target victims. The consequences on the flooding received by the target causing the system or the network become down or unavailable. Those attacks are called denial of service. Denial of service generated by one attacker to attack one target. And the distributed denial of service attacks generated by many hosts connecting together, cooperating together, trying to attack the same target. The differences between distributed denial of service and denial of service is that denial of service attacks they using one attacker, but in the distributed denial of service attacks they using many attackers to attack to the same target. To prevent denial of service attacks, the company or organization trying to implementing security mechanism by deploying firewall or using intrusion detection system or intrusion prevention system, and the most expensive is that they using DDoS detection with the special hardware. From the statistic shows that almost 90% DDoS traffic generated using TCP or HTTP traffic. They will cooperating with the another attacker to attack to the same target. The main problem in intrusion detection system or intrusion prevention system is that they has limited ability to detect the normal traffic. Normal traffic will be categorized as a DDoS traffic, and DDoS traffic will be categorized as a normal traffic. This condition called as a false positive detection. In our research, we try to increasing the capability of IDS or IPS on detecting the denial of service attack using machine learning. As we know that IDS or IPS use two methods for detecting the incoming traffic to the network by using the signature detection or based on anomaly detection. But in our research, we try to implementing our machine learning algorithm in our DNS. On this research, we use some previous experiments in our research. The first one, the paper number 1, said that the distributed denial of service attack generating huge packet by several attackers to send a flooding package to the victim device. Paper number 5 said that he conducting a research on detecting DDoS traffic using decision tree and naive bias. The result of their research said that the decision tree more accurate compared to the naive bias. The paper number 5, they only using a dataset, not the real pickup packet or real network packet. And the paper number 10 in research held by L. Aguila, they conducting DDoS detection attack they use ICMP version 6 DDoS attack on their papers. They did not include any other protocol like TCP or UDP flood attack. Their result shows that the KNN provide faster detection compared to any other machine learning algorithm, like support vector machine, naive Bayes, and neural networks. On this research, we using dataset. We use CICIT 20 and 70 dataset. CICIT 20 and 70 dataset contain the largest general attacks and packets that are considered normal and relevant to the real-world data in PCAP format. This dataset we using as a data frame for on our machine learning algorithm, and the real data of data test we are using the real PCAP network traffic format, and we convert it to the CSV format. In CICIT 20 and 17 dataset, it has the 84 attributes, and we will reduce it on the future selection process to 4 attributes. The machine learning algorithm that used in our research, we use k-nearest neighbor and decision tree. I'm sorry for you all that this is not my expertise area, and in this presentation I will only explain to you from the network engineering perspective. K-nearest neighbor is a machine learning algorithm for classifying based on the majority of the nearest neighbor object with the nearest neighbor coverage of K. And the classifying decision tree is a classifying method that uses the representation of tree structure to solve a problem. This is the flowchart of our research. First, we try to creating some network topology. In our topology, the host consists of 5 hosts. 3 hosts as a attacker, DDoS attacker, and 1 host is a normal client. They sending normal traffic to the target, and the last host is target or victim device. Before we analyzing the packet, first we start capturing before the attacking phase is begin. The output of the capturing is on a PCAP format, and we convert it to the CSV format. After we get the CSV format, and then we doing some feature selection that will be used in our machine learning algorithm in KNN training and decision tree training. After the KNN testing and decision tree testing, we will get the result and the conclusion in our research. And this is the network topology. Host 1, he will try to sending SYN TCP flags to the target. Host 1 is sending 100 SYN flags packets every second to the target, and host 2, he will try to sending 100 GET method HTTP requests to the target every second, and host 3, he will sending 100 empty UDP message to the victim target. Host 4, he will sending the normal traffic like ICMP ping request reply, TCP connection using normal HTTP request, and normal DNS query to the host 5 or victim host. As you can see, this is the traffic generated by the source host. From the feature selection process, we will get this following attribute with the highest priority. The attribute 1 that we'll use in our research. The first is the valid packet length standard. This is the minimum value of the bytes of packet length in the backward direction. The average packet size is the average size of each packet. It is important to notice that the packet length specifies the size of the whole packet, including the header, trailer, and the data that's sent on the packet. But packet size specifies only the size of the header on the packet. The third, the attribute that we will use is a flow duration. Flow duration is the total duration of the flow. And the last is flow IAT standard is the value of the inter-arrival time of the flow. From the experiment result shows that the decision tree gives the higher accuracy on detecting DDoS traffic or DDoS attack compared to the KNN. And this is on the result of our research. The conclusion in our research, we conclude that the decision tree provides higher accuracy compared to the KNN on detecting DDoS traffic in our network topology. And for the future works, we will like to implementing real-time DDoS detection using machine learning in the network device. Okay, thank you. That's all for our presentation, and goodbye.